This is Merkle Trees by Hardeep Doku. Um, my student ID is EM06651. What is a Merkle tree? A Merkle trees are binary trees made of pointers and they are hashed together. They work from bottom up, and each pointer is hashed together to create a new, like eventually create a new tree. So L1 and L2 are hashed together, and then they move up, like they join, and then they move up, and then the L3 and L4 then hash together, and then those two, the outcomes of those two are then put together to um, create the top hash, which is the root, which is the digital footprint. Well, it's like it creates a digital footprint. It's the end of the line. It's like what they need. They could go through. They could use the root and check every different version or every different transaction. This is just another example about how Merkle trees work. On the left, we have a regular binary tree, how it works top down, and on the right, it shows that it's inverted and they work bottom up. What are the uses? The Merkle trees are used in cryptocurrencies, blockchains, bitcoins, transferring data to multiple places, creating secure transactions, and finding discrepancies in data. There are multiple more uses for Merkle trees, but these are more like the main ones. The benefits of it: they are fast, efficient, and secure. In blockchains, Merkle trees allow us to allow the transaction to be quick and be secure. It goes through a verification process and usually has like a transition key and everything. The transactions are irreversible, so they are one way. So that once they go through, you have to create a whole nother transaction if you want to send anything back. They ensure data is consistent and prevent any changes of data. So Merkle trees can be used to send data to multiple areas. So they help ensure with they have a verification process that they use to send. When they send the data out, it checks if the data was correctly transferred or not. Some blockchains use private keys, and they use very little space, so you could have multiple, and they are very like space efficient. While transferring data, it creates verifiable logs, which you can go back and check and see everywhere the data went and how it was transferred and everything. It compares ledgers to confirm data that is correct in both ends. Data can be broken down into small pieces and traversed over multiple different networks, and it creates a digital footprint. The efficiency. Merkle trees are actually very efficient. The trees try to keep efficiency of 0n or 0 log n, or my bad, O. They keep detailed records and the root is used to trace all the steps in the transaction. These are my references.